Welcome to our comprehensive guide on data integration. In today's digital world, organizations collect information from a wide variety of sources, databases, cloud services, spreadsheets, and more. But how do we bring all this data together to create a single, unified view for analysis and reporting? That's where data integration comes in. This process involves combining data from different origins, making it accessible and meaningful for business intelligence and decision-making. Throughout this video, we'll explore the core techniques, challenges, and best practices that help organizations turn scattered data into actionable insights. Let's dive in and discover how data integration can transform your approach to analytics. Data integration is more than just a technical process, it's a strategic necessity. Imagine trying to analyze sales trends when your customer data is in one system, your inventory in another, and your marketing results in yet another. Without integration, you're left with fragmented information and incomplete insights. By unifying data, organizations can see the full picture, identify patterns, and make informed decisions. This holistic view is essential for accurate reporting, regulatory compliance, and staying competitive in today's fast-paced market. In the next scenes, we'll break down the main techniques used to achieve seamless data integration. There are several key techniques for integrating data, each with its own strengths and use cases. The most common approaches include ETL, extract, transform, load, ELT, extract, load, transform, data virtualization, and data federation. Each method addresses different integration needs, from moving large volumes of data to providing real-time access across systems. Understanding these techniques is crucial for choosing the right strategy for your organization. In the following scenes, we'll explore each method in detail, highlighting how they work and when to use them. Start with ETL, which stands for extract, transform, load. This classic data integration technique involves three main steps. First, data is extracted from various sources such as databases, files, or cloud services. Next, it's transformed, cleaned, formatted, and standardized to ensure consistency. Finally, the processed data is loaded into a central repository like a data warehouse where it's ready for analysis. ETL is ideal for batch processing and is widely used in business intelligence projects. It ensures that data is accurate, reliable, and structured for reporting. First step in ETL is extraction. Here, data is pulled from multiple sources, which could include relational databases, flat files, APIs, or even web services. The goal is to gather all relevant information, regardless of its original format or location. This step often involves connecting to different systems and handling various data types. Proper extraction ensures that no critical data is missed and sets the stage for effective transformation and loading. Extraction tools and connectors play a vital role in automating this process and maintaining data integrity. Once data is extracted, the next phase is transformation. This step involves cleaning the data, correcting errors, converting formats, and applying business rules. For example, dates might be standardized, duplicate records removed, and missing values filled in. Transformation ensures that the data is consistent and ready for analysis. It's a critical stage because poor data quality can lead to inaccurate insights. Advanced transformation processes may also include data enrichment, where additional information is added to enhance the dataset. Final step in ETL is loading the transformed data into a target system, usually a data warehouse or data mart. This centralized repository is optimized for querying and reporting, making it easy for analysts to access and use the data. The loading process can be scheduled to run at specific intervals, such as nightly or weekly depending on business needs. Efficient loading ensures that the data is up to date and available for timely decision-making. Monitoring and validation are also important to confirm that the data has been loaded correctly. ELT, or extract, load, transform, is a modern variation of ETL. In this approach, data is first extracted and loaded into the target system, such as a cloud data warehouse. The transformation happens after loading, taking advantage of the processing power of modern databases. ELT is particularly useful for handling large volumes of data and supports real-time or near real-time analytics. It's commonly used with big data platforms and cloud-based solutions, offering flexibility and scalability for growing organizations. ELT, the heavy lifting of data transformation, is handled by the target system itself. After extraction, raw data is quickly loaded into a powerful data warehouse, where complex transformations and aggregations are performed. This approach leverages the scalability of cloud platforms, making it ideal for organizations dealing with massive datasets. ELT also supports parallel processing, which speeds up data preparation and enables faster insight. As cloud technology evolves, ELT is becoming the go-to method for many modern data integration projects. Data virtualization is a technique that allows users to access and query data from multiple sources without physically moving it. Instead of copying data into a central repository, virtualization creates a virtual layer that connects to different systems in real time. This approach provides a unified view of the data, enabling quick access and analysis. Data virtualization is especially useful when you need up-to-date information from diverse sources or when data movement is impractical due to size or security concerns. One of the main advantages of data virtualization is its ability to provide real-time access to data across multiple systems. This means users can run queries and generate reports without waiting for data to be moved or transformed. Virtualization also reduces storage costs, since data isn't duplicated. It's a flexible solution for organizations that need to integrate data quickly and efficiently, especially when dealing with complex or distributed environments. However, it's important to consider performance and security when implementing virtualization. Data federation is another integration technique that creates a unified view of data from multiple sources. Unlike ETL or ELT, federation doesn't physically move or transform data. Instead, it uses a virtual database that connects to different systems and presents the data as if it were in a single location. This approach is ideal for organizations that need to combine data from various departments or external partners without disrupting existing systems. Federation supports on-demand access and simplifies reporting across diverse data sources. Data integration can be performed in batch mode or in real time. Batch integration involves processing large volumes of data at scheduled intervals, such as nightly or weekly. This method is efficient for handling historical data and is commonly used in ETL processes. Real-time integration, on the other hand, updates data continuously as new information becomes available. This is essential for applications that require up-to-the-minute insights, such as fraud detection or customer engagement platforms. Choosing the right approach depends on your business needs and technical capabilities. Organizations integrate data from a wide range of sources. These can include relational databases, cloud storage, spreadsheets, CRM systems, and even social media platforms. Each source may have its own format, structure, and access protocols, which adds complexity to the integration process. Understanding the nature of your data sources is the first step in designing an effective integration strategy. In the next scenes, we'll discuss how to connect and manage these diverse sources for seamless data flow. Relational databases are a common source of business data. Integration tools use connectors and drivers to establish secure connections, extract data, and manage updates. These connections must be configured to handle authentication, data types, and network security. Properly managing database connections ensures that data is transferred accurately and efficiently, minimizing the risk of errors or data loss. Many integration platforms offer pre-built connectors for popular databases, simplifying the setup process. Cloud storage and cloud-based applications are increasingly important data sources. Integration with cloud services requires handling APIs, authentication tokens, and data formats like JSON or XML. Cloud integration enables organizations to combine on-premises and cloud data, supporting hybrid environments. It also allows for scalable storage and processing, making it easier to handle large or rapidly growing datasets. Security and compliance are key considerations when integrating cloud data. Not all data comes in neat rows and columns. Unstructured data such as emails, documents, images, and social media posts presents unique integration challenges. Specialized tools and techniques are needed to extract, process, and integrate this type of data. Natural language processing, image recognition, and text mining can help make sense of unstructured information. Integrating unstructured data expands the scope of analysis and provides deeper insights into customer behavior and market trends. One of the biggest hurdles in data integration is ensuring data quality. Inconsistent formats, missing values, duplicates, and errors can all undermine the reliability of your integrated data. Data quality management involves profiling, cleansing, and validating data before and after integration. Automated tools can help identify and correct issues, but human oversight is often necessary for complex cases. High-quality data is essential for accurate analysis and trustworthy reporting. Data mapping is the process of defining how fields from different sources correspond to each other. This step is crucial for ensuring that data is accurately combined and interpreted. Mapping tools allow users to create visual representations of source and target fields, apply transformation rules, and handle data type conversions. Effective data mapping reduces errors and streamlines the integration process, making it easier to maintain and update as systems evolve. Master data management, MDM, is a discipline that ensures the consistency and accuracy of key business data across the organization. MDM involves creating a single authoritative source for critical data entities, such as customers, products, or suppliers. By integrating and synchronizing master data, organizations can eliminate duplicates, resolve conflicts, and maintain data integrity. MDM is a foundational element of successful data integration strategy. Metadata is data about data. It describes the structure, origin, and meaning of your datasets. Effective metadata management is essential for successful data integration. It helps users understand where data comes from, how it's transformed, and how it should be used. Metadata repositories and catalogs provide centralized access to this information, supporting data governance and compliance. Good metadata management also makes it easier to troubleshoot issues and maintain integration workflows. Data governance refers to the policies and processes that ensure data is managed responsibly throughout its lifecycle. In the context of integration, governance involves defining roles, responsibilities, and standards for data quality, security, and privacy. Strong governance frameworks help organizations comply with regulations, protect sensitive information, and maintain trust in their data. Governance is an ongoing process that requires collaboration between IT, business, and compliance teams. Security is a top priority when integrating data from multiple sources. Sensitive information must be protected during extraction, transfer, and storage. Encryption, access controls, and secure protocols are essential for safeguarding data. Regular audits and monitoring help detect and respond to potential threats. By building security in every stage of the integration process, organizations can minimize risks and ensure compliance with data protection regulation. As organizations grow, their data integration needs become more complex. Scalability is the ability to handle increasing volumes, variety, and velocity of data without sacrificing performance. Scalable integration solutions use distributed architectures, cloud resources, and parallel processing to manage growth. Planning for scalability ensures that your integration platform can support future business needs and adapt to changing technology. Automation plays a key role in modern data integration. Automated workflows reduce manual effort, minimize errors, and speed up data processing. Integration platforms offer features like scheduling, monitoring, and error handling to streamline operations. Automation also supports continuous integration and delivery, enabling organizations to respond quickly to changing business requirements. Investing in automation can significantly improve the efficiency and reliability of your integration processes. Ongoing monitoring and maintenance are essential for keeping data integration systems running smoothly. Monitoring tools track data flows, detect anomalies, and alert administrators to potential issues. Regular maintenance includes updating connectors, optimizing performance, and addressing security vulnerabilities. Proactive monitoring and maintenance help prevent downtime, ensure data accuracy, and support business continuity. Using the right data integration platform is a critical decision. Key factors to consider include compatibility with your data sources, scalability, security features, and ease of use. Some platforms offer pre-built connectors and templates, while others provide advanced customization options. Evaluating your organization's current and future needs will help you select a solution that supports your integration goals and maximizes return on investment. Data integration can be deployed in the cloud, on-premises, or in hybrid environments. Cloud integration offers scalability, flexibility, and lower upfront costs, making it ideal for organizations with dynamic needs. On-premises solutions provide greater control and may be necessary for sensitive or regulated data. Hybrid integration combines the best of both worlds, allowing organizations to leverage cloud resources while maintaining on-premises systems. The right deployment model depends on your business requirements and regulatory environment. APIs, or application programming interfaces, are essential for connecting modern data sources. APIs enable real-time data exchange between systems, supporting both cloud and on-premises integration. They provide standardized methods for accessing and updating data, making it easier to integrate new applications and services. API management tools help monitor usage, enforce security, and maintain performance. Leveraging APIs accelerates integration and supports digital transformation initiatives. Data integration supports a wide range of business use cases. Common examples include consolidating customer data for personalized marketing, combining financial data for reporting, and integrating supply chain information for operational efficiency. Integration also enables advanced analytics, machine learning, and artificial intelligence by providing comprehensive datasets. Understanding your specific use cases will help you design effective integration solutions that deliver real business value. Customer 360 View is a unified profile that combines data from sales, marketing, support, and other systems. By integrating these sources, organizations gain a complete understanding of each customer's interactions, preferences, and needs. This holistic view enables personalized experiences, targeted campaigns, and improved customer satisfaction. Building a Customer 360 View requires robust data integration and strong data governance practices. Financial reporting often requires data from multiple systems, such as accounting, payroll, and sales platforms. Data integration streamlines the process by consolidating financial information into a single reporting environment. This reduces manual effort, minimizes errors, and ensures that reports are accurate and up-to-date. Integrated financial reporting supports better decision-making and regulatory compliance. Integrating supply chain data from suppliers, manufacturers, and distributors provides end-to-end visibility into operations. This enables organizations to optimize inventory, reduce costs, and respond quickly to changes in demand. Supply chain integration also supports real-time tracking, predictive analytics, and improved collaboration with partners. Effective integration is key to building resilient and agile supply chains. Healthcare organizations integrate data from electronic health records, lab systems, billing platforms, and more. This integration supports coordinated care, population health management, and regulatory reporting. By unifying patient data, providers can deliver better outcomes and improve operational efficiency. Healthcare data integration must also address strict privacy and security requirements to protect sensitive information. Retailers integrate data from point-of-sale systems, e-commerce platforms, inventory databases, and customer loyalty programs. This unified data enables personalized marketing, demand forecasting, and inventory optimization. Retail data integration also supports omnichannel strategies, allowing customers to shop seamlessly across online and offline channels. The result is a better shopping experience and increased sales. Internet of Things, IoT, generates vast amounts of data from sensors, devices, and machines. Integrating IoT data with business systems enables real-time monitoring, predictive maintenance, and automation. IoT integration requires handling high-velocity data streams and ensuring interoperability between devices and platforms. Successful IoT data integration unlocks new opportunities for innovation and efficiency. Data integration involves combining structured and unstructured data from a variety of sources, including social media, sensors, and transactional systems. Specialized tools and platforms are needed to process and analyze these massive datasets. Big data integration supports advanced analytics, machine learning, and data-driven innovation. Scalability, performance, and data quality are key considerations in big data projects. Data Lake is a centralized repository that stores raw data in its native format. Data integration tools can ingest data from multiple sources into the lake, where it can be processed and analyzed as needed. Data lakes support flexible storage and are ideal for big data and advanced analytics projects. However, managing data quality and governance in a data lake environment requires careful planning and robust integration practices. Data warehouses are designed for structured, high-performance analytics. Integration processes load cleaned and transformed data into the warehouse, supporting business intelligence and reporting. Data warehousing integration ensures that users have access to reliable, consistent information for decision-making. It also enables historical analysis and trend identification, providing valuable insights into business performance. Successful data integration projects follow a set of best practices. These include defining clear objectives involving stakeholders, documenting data flows, and establishing data quality standards. Regular testing, monitoring, and continuous improvement are also essential. By following best practices, organizations can reduce risks, improve outcomes, and maximize the value of their integrated data. Despite the benefits, data integration projects can encounter challenges. Common pitfalls include underestimating data complexity, neglecting data quality, and failing to plan for scalability. Lack of stakeholder engagement and poor documentation can also lead to project delays or failures. Being aware of these risks and proactively addressing them will increase your chances of success. Field of data integration is constantly evolving. Emerging trends include the use of artificial intelligence and machine learning to automate data mapping and quality checks. Cloud-native integration platforms are becoming more popular, offering greater flexibility and scalability. Real-time and event-driven integration are also on the rise, enabling faster insights and more responsive business processes. Staying informed about these trends will help you future-proof your integration strategy. Data integration professionals need a mix of technical and business skills. Technical expertise includes knowledge of databases, programming, and integration tools. Business skills involve understanding data requirements, communication, and project management. Continuous learning is important as new technologies and best practices emerge. Building a strong skill set will help you succeed in this dynamic and rewarding field. Wrap up: data integration is the foundation of effective analytics and reporting. By combining data from diverse sources, organizations gain a unified view that supports better decision-making. We've explored core techniques like ETL, ELT, virtualization, and federation, as well as best practices in real-world use cases. Remember, successful integration requires careful planning, strong governance, and ongoing improvement. With the right approach, you can unlock the full potential of your data. Now that you have a solid understanding of data integration, consider evaluating your organization's current data landscape. Identify key sources, assess integration needs, and explore available tools and platforms. Engage stakeholders and develop a roadmap for your integration journey. By taking these steps, you'll be well positioned to harness the power of unified data for analytics, innovation, and business growth.